All right, so we are continuing on to page 12. We're going to do page 12, 13, and then end with page 14. Cool. So we may have already done example 3 from previous days, but let's go ahead and move on to at least the practice. Okay, so it says to go ahead and find the indicated trig ratio and write the answers as a reduced fraction using Desmos. So, right, we know our trig ratios follows by SOHCAHTOA. And so this is how I like to go ahead and write it out. Just so that already, right, we already have that ratios if we're talking about sine, cosine, or tangent. So for part A, it says that we're finding the tangent of A and then the tangent of B. So already I'm going to go ahead and write tangent is opposite, no, I got that wrong. It's opposite over your adjacent side. Let me go ahead and fix this guy. Okay, so I have opposite over adjacent, opposite over adjacent. Now, it says tan of A and tan of B, so we are looking at two different reference angles. Let's go ahead and start with tan of A. This one I'm going to go ahead and do in yellow. Here's my angle A, and now I'm going to go ahead and label my sides, right? So, opposite of A is my 45. Adjacent of A is the 28, and always across from my right angle is going to be the 53, the hypotenuse. Cool. So already if I'm looking at tangent of A, I'm doing the opposite over adjacent, so I have 45 all over 28. Okay, this is when I'm going to go ahead and switch to my calculator, so I really advise us to go ahead and use Desmos. And then I'm going to plug in 45 divided by 28. Now it gives me a decimal, but this little fraction symbol up there will go ahead and turn it into a fraction. So right away, I have 45 over 28. That means that our decimal, right, our fraction does not reduce anymore, so it just leaves it at that. Okay, I'm now going to go ahead and look at tangent of B. So different reference angle, I'm looking at angle B. Then that changes my opposite and adjacent side. So opposite of B is the 28. Then the adjacent of B is the 45. And then the hypotenuse stays the same. Okay, hypotenuse is always going to be the longest side, which is across from your right angle. So tangent of B, if I'm looking at my green, I have 28 over 45. Same exact thing. I'm going to go and plug in 28 all over 45. And this fraction does not reduce, so we leave it as 28 over 45. Okay, let's go ahead and do example B. This time looks like we are doing tangent of A, tangent of B again. Again, tangent means that we are doing opposite over adjacent. Okay, so let's go ahead and start with A. Okay, across from A is my opposite. Right next to A is my adjacent. Across from my right angle is my hypotenuse. So tangent of A, already my opposite over the adjacent is 56 over 33. I'm going to go and type in 56 divided by 33. And this one also does not reduce, so that is my finalized answer. Okay, let's go and move on. Reference angle B. So across from B is the 33. That's my opposite side. Right next to B is my 56. My hypotenuse stays the same. So opposite over adjacent looks like we have 33 over 56. And let's see if this reduces at all. Nope, does not reduce. That is my finalized answer. All right, let's go and do example C. So this time we are changing what we are finding. So cosine, if I look back up, is adjacent over my hypotenuse. Sine is opposite over hypotenuse. So I'm just going to go and write that in. Adjacent over your hypotenuse. Sine is opposite over hypotenuse. Okay, still exact same thing where we're looking at two different reference angles. So let's go ahead and do cosine of A first. Go and label it as 9 is the opposite side, 12 is the adjacent side, 15 is my hypotenuse. So if I'm looking at adjacent over hypotenuse, looks like my fraction is 12 over 15. Now this is when I'm going to come back to my calculator because I'm not sure if it reduces, but I'm going to go and double check. If I press my little symbol guy, what? No way! My fraction changes. Instead of 12 over 15, we are looking at 4 over 5. So 4 over 5, or 4/5, would be my answer. Okay, let's go and look at sine of b. So now I'm looking at my b angle. I'm going to go across, which is my opposite side, that is the 12. Right next to it, which is the adjacent side, that is my 9. And always and forever, across from my right angle is my hypotenuse. So then it does change, right? Opposite of b is 12. My hypotenuse is 15. And we see that it's the same thing as cosine of a, where it's going to go and reduce to 4/5. And that is the answer. Okay. I want you guys to go ahead and try the next page. Try D and E. Same exact thing. Use SOHCAHTOA. And figure out what trig function, and then figure out your sides. And then you guys are able to go ahead and get your ratios. All right, part D. So I'm looking at R and S. Cosine specifically, so cosine again is adjacent over hypotenuse. Let's go and look at first cosine of R. So here's R. I'm going to go and label the sides. Here's the opposite. 20 is the adjacent. Across from my right angle is my hypotenuse. So cosine of R is going to be adjacent over hypotenuse, so I have 20 over 25. Same exact thing. I'm going to go and plug in 20 over 25 in my calculator, and it does reduce to 4 over 5. Okay. Moving on to cosine of S, my reference angle does change. I'm going to go and label it now. I have the opposite side to be 20. I have my adjacent side to be 15. And again, my hypotenuse stays the same. So now I have adjacent over my hypotenuse. It looks like I have 15 over 25. And let's see if that reduces. Yay, it does, to 3 over 5. Cool. All right, let's look at part E. So same exact thing. It looks like I'm looking at angles R and S, but specifically we're looking at sine, right? I know that sine is opposite over hypotenuse. So if I'm looking at sine of angle R, here's my R. I'm going to label my sides. I have opposite to be 24, adjacent side to be 10, and always and forever across from my right angle is my hypotenuse. Okay, so I'm looking at opposite over hypotenuse. It looks like we have 24 over 26. I'm going to go to my calculator, plug that in. 24 over 26. Let's see if it reduces. Yep, it reduces to 12 over 13. Okay. Same exact thing. I have sine of S. So that means I have the opposite side to be 10, the adjacent side to be 24. And again, always and forever, across from my right angle is 26. Okay, so the opposite would be 10. The hypotenuse would be 26. Let's see if it reduces. 10 divided by 26. Nice, we have 5 over 13. All right, 2 more to go, guys. So here we have 2 different reference angles as well as 2 different functions, right? So I have cosine and tangent. Cosine, we know, is adjacent over hypotenuse, whereas the tangent is opposite over adjacent. Okay, so let's go ahead and do the first one. Cosine of R. So here's angle R. I'm going to label my sides. I have the opposite side to be the 16. I have adjacent side to be 30. Hypotenuse to be 34. Okay, so my adjacent is 30 over the hypotenuse, which is 34. Let's see if this guy reduces. 30 divided by 34. That gives me a ratio of 15 over 17. All right, and then we have the other function where we have the tangent of angle S. So same exact process, I'm going to label my triangle. Right, I have the opposite to be 30, the adjacent to be the 16, my hypotenuse stays the same. Okay, tangent is opposite over adjacent, so I'm going to have my opposite side, which is 30, over the adjacent, which is 16, and I'm going to see if that reduces. Let's see. Nice, it reduces to 15 over 8. And that is your answer. Okay. All right, final stretch. It says use the right triangle PQR with acute angles P and R, so as shown at the right. Find the trig ratios. You are going to go ahead and write your answers as fractions in the simplest form, right, using Desmos in this case. Let's go and focus on the first box. I have sine of P, cosine of P, tangent of P. So great, right? We're all looking at the same reference angle right here. Okay, so I'm going to go and label it. So I have the opposite side to be 5, adjacent side to be 12, and then my hypotenuse to be 13. And then let's start going. So I have SOHCAHTOA, right? Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. My opposite side looks like is 5. My hypotenuse is 13. I'm going to type in 5 over 13, see if it reduces. Nope, we just keep it the same. Okay, cosine. My adjacent side is 12. My hypotenuse is 13. I'm going to go ahead and plug in my calculator. Does it reduce? Nope, it stays the same. And last but not least, I have tangent of P, so I have the opposite over my adjacent side. So I have 5 over 12. And again, let's see if this reduces. Nope, it stays the same. So there are my 3 trig ratios for angle P. Okay, and then we have angle R. So I'm just going to go ahead and take this guy. I'm going to go ahead and copy it, paste the image so that we have that work for angle P. Otherwise, we can go and erase this guy. And let's focus on angle R. So same exact thing for going on to angle R, right? Sine is still the opposite over hypotenuse, cosine is still adjacent over hypotenuse, tangent is opposite over adjacent. So if I'm labeling my triangle, my opposite side now is 12, my adjacent side is 5, my hypotenuse is going to be 13. So my opposite is 12 over my hypotenuse, which is 13. So I'm looking at 12 divided by 13. Now we already did that one right here, and we saw that that is the most reduced that we could do. So that is the answer. Right? Then we have cosine of R, so I'm looking at my adjacent side over my hypotenuse. Same exact thing. We did that over here. Right? So see that we don't reduce it. We keep it the same. Last but not least, the tangent. So the opposite over the adjacent, which is 12 over 5. Now this one we do have to go and check. And it stays the same. Nice. So that is all for today's notes.